Hello everyone, my name is Divyansh and I will be going over the demo of lab 5 was705 course, and I will be going over a little bit of hardening part that was done from my side to contribute into the team lab. So basically the Docker container hardening, removing its root privileges, and also the permission level hardening onto the SQLite database that stores basically the metadata of our application, and everything else like adding in TLS level certificates, enforcing HTTPS, and that hardening was also done along with mod security rules getting added in order to mitigate the known vulnerabilities that we have found. So basically, let's go over. So there's a script that I have created to basically run over the demo hardening part, and that is what I will just um, execute. So this basically shows us the container that is running along with the privileges. So basically this shows the container name, and also what its UID is. So we can see here that there is no UID 0 or something. That basically shows us that there is no root users allowed into this. um, not allowed in the sense, but on the non-root users are running the container. um, Along with non-root enforced as container at config level as well. We can see here that user 2000 is configured at the config level. The file level permissions of our local files which are used by the Docker container is also owned by ABS, which is basically a specific user who runs the Docker um, container. And we can see here that no Ubuntu or root users are owning this container. Along with the permissions here we can see are very restrictive. um, the SQLite database also has is owned by ABS and only has very strict permissions. So read write level permissions, and then also read level permissions on a group level, and then no permissions to others. Along with that, we can see that there is a negative test that has been done. There was a command that was ran for testing to see if some other user can access SQLite database, and permission denied was the result. Along with the Docker group membership, we can see right here it's correct as well. Now we will just go over the custom rules that we have created, and we will be able to see that custom rules. There is also CRS config that has been added. So basically, community rule set has been added along with our custom rule. This rule basically stops the deletion of root user, which was the known vulnerability that we have found in this application, which basically whenever a delete request gets sent to the API users endpoint along with the UUID of the root user, the code actually looks for root as in string instead of looking at the root level UUID. Now that is a vulnerability, and root user should not be deleted. And this basically means that this rule, which is stopping a delete method HTTP request, that is sent to this endpoint, which is API users endpoint, along with the UUID of root user. Now, this UUID of root user will not get changed after it is made. So we can just hard code that exact same UUID into this rule so that uh, the root user cannot be deleted. Now, in demonstration purposes, I had to keep changing the UUID because I had to to keep creating the disposable containers in order to test my theory. But in production environments or any real life deployments of this specific application, UUIDs won't change because people don't usually redeploy their Docker containers with new configs every time. The root users will stay the same even though the container gets updated. The user UUIDs all stay the exactly the same. So this is what it will stop. Let's look at the TLS level hardening. So audiobookshelf.local was the domain that was chosen. We can see here that HTTP is used, and in order to demonstrate that it directly redirects to HTTPS method is also one of the hardening steps that we have done. We can see that connection is secure. It is the certificate was added into Mozilla, and our audiobook shelf is opening on HTTPS. That means that the hardening part is done. Um, Mod security has also been added for our known vulnerability, and the system level permissions and the Docker permissions have also been hardened. Thank you so much, and over to my next teammate.
Hi, I'm Pawan, and I will be talking about Snyk findings. So, Snyk is one of the three tools that we use for static code analysis. And based on Snyk, we found out that most of the vulnerabilities identified were related to XSS and directory traversal. We tried some of them, and all of them turned out to be false positives. We didn't try like all of them, but most of them they turned out to be false positives. So, for example, here one of the findings was that a file path called ebook file path used a user input without proper sanitization. We came to the conclusion because here the website uses rds.send file to serve ebook file path, and then when we look closer into the file, we found out that ebook file path is derived from ebook file.metadata.path, and then since metadata is controlled by the user, we tried to exploit it in the API/library, and we also tried to do it in items. So the first thing is to get the library ID. We got a library ID, and then based on the library ID, we tried to get all the items ID, and we randomly used one item ID from here. So now using the same item ID, we tried the very simple directory traversal, which is /etc password, and then we cannot get etc password, so which means it does not work. And then the other one was we encoded the slash, and then it says not found. We also tried double encoding, the same problem. It didn't work. And then along with that, it gave us many lines of code that were probably not properly monitored. There are many vulnerabilities in the report. So one of the finding was it has one XSS vulnerability that it's not a vulnerability that's really what we say. It's not destructive or anything, but when we try to put a XSS command, it displayed it instead of the database name, but it didn't execute because the front end it encoded all the what we call it. It encoded all the commands. And then I also tried one cookie grabber bash, Python server, which did not work because when I tried to upload my localhost Python server into the script, the front end, the view front end uses vhtml, which basically sanitizes all the functions and plugins. So whatever you types, it's sanitized into $LT. So this one did not work. But one of the good finding is that we have a rate limiting in login, but we don't have rate limiting in a normal GET request. So when we tried a DOS attack, 5,000 request, it actually accepted it, and then our CPU jumped from 0.03% to 38%. For this, we used a very simple fail2ban with a very simple regex, and then it successfully blocked most of the requests. So if you want to try this, we can just go and run this GET request to API libraries. And doing so, all of the requests gave us 000, which means the request did not pass through. Let me go to our jail filter, what kind of regex it's looking at. So it's basically looking at any GET request to /API. And then if the request is, let me show the filter. Here. So max retry 10 in 60 seconds. The ban will be for 1 minute. So simple one. So sudo systemctl stop fail2ban. I'm going to stop the whole thing. And then if I want to run the same command again, it actually works now. The blocking is gone. So that's it for my part. Thank you.
Hi, my name is Harleen and I'm part of group 4 to demonstrate my lab 5. So I have tested 4 findings under authentication and API security, open redirect, no SQL injection, logic bypass and cookie settings. So the first 3 turned out to be false positives after testing. So I'll focus on the one real issue that I found, the missing security flag on the session cookie and the fix I applied for that. So the scanner flagged the session cookie configuration. So let's log in normally to check like what the issue is, and we can see over here like what the cookie server sends back. So as we can see over here that we have the only HTTP over here, which means that there is no secure flag on the cookie, and it can be sent over plain HTTP and no HTTPS, which means that it can be intercepted on unencrypted connection, which is a real issue. So I have fixed it using the NGINX virtual patch. I basically put a NGINX reverse proxy in front of the application that rewrites the cookie on its way out without touching the app source code. So let me show you the file that I have used. So this line up here, that is proxy cookie flags, here it adds the missing secure and same site attributes to the connect.set key as it passes through the proxy. So after this, I would like to show you the that the configuration has been applied. So here it says that the configuration file is good and the configuration is successful. So after this, what I will do is I will reload it. So it's reloaded. Now what I will do is I'll just run it again using the same port, that is 13378, on which our audio shelf is running. So here we can see is it's still HTTP only. And now if I run it using my NGINX port, that is 8080, we can see the difference. So as we saw it over here that there is no secure flag, but once we run it using the port 8080, now it is secure and it has the same site. Both are present there now, so which means that it is a fix. So one last thing before anything else, we will make sure that the patch does not break anything. So for that we will just do the healthy check. So this is a confirmation that even after doing the NGINX proxy, it doesn't break anything and our app works fine. So as we can see over here that it says okay, which means that there is no problem with the running of the app after applying the fix. So it works normally through the proxy and no login or functionality was broken by this fix. So that's it for my part. Thank you.
Hi, my name is Salah, and today I'm covering the testing I did for secret management and rate limiting on audio bookshelf. Most of these scanners, or most of the scans flagged findings turned out to be false positives, but I found two genuine vulnerabilities, and I'll show you both along with the fixes or the patching steps I did or built for them both. Let's start with secrets. The scanner flagged 6 spots in the code as hard-coded secrets. I checked each one manually, and they turned out to be things like error message and test data. So all 6 were false positives, but I wanted to go further and test the real secret the app uses to log people in. So the secret is stored in the app's own database. So instead of logging in normally, I'm putting it straight from there. So I'm going to run this command to extract the secret first. So this is the real secret in plain text. Now I will use it to build my own logging token from scratch and just claim I'm the admin or I'm the root. So I am going to save this first in the in a variable, and then after that I'm going to use this command or this script to create a token from me. And as you can see, a token was generated using the secret, and I have specified the secret variable here. And there, as you can see, there was no password used. So now if I am going to use the token that was just given to me, and now if I'm going to paste it here, sorry, just give me a second. So now I have pasted the token here. Now if I can curl, so as you can see, it worked instantly. No password was actually used, but the server treated me as the real admin. That's serious issue. Anyone who can read that one file can become any user on the system. So I'm gonna patch this issue at last. I'm going to patch all the issues at last. But now I'm going to also explain the issue that was found in rate limiting. So let me clear the page. So for the rate limiting, this checks whether the app stops someone from spamming the same request over and over. The scanner flagged several endpoints for this, including the login. I have tested the login, and it actually where like the rate limiting was working there. So it blocks you after too many tries. So I won't spend time showing that. But for the one I want to show you, which is the critical endpoint that was flagged and not protected at all, which was the backup endpoint. And I want to show you the most serious one, as I said now, which is the backup endpoint. So what I am going to do, um, I'm going to create a token first and save it in a variable. So let me just copy this command. So as you can see, I was able to get the token. And then after that, what I am going to do is ask the app to do a 10 backup requests, one after the other, as fast as possible. It just did them all. So as you can see, it's doing 1, 2, 3, 4, 5, and it did not even it was not delayed, it did not stop, it did not block. So any attacker, if they did or try to overwhelm the system, they can using this endpoint. So now to check whether the backups was actually done or not, I'm going to check the logs. So as you can see here, the logs confirms it. All 10 backups actually run in full back-to-back. If someone kept spamming this, it could slow the whole server down for every user. So now I'm going to start with the patching parts. So secret issue, the database file was the issue, and it could be read by anyone on the system. So if I'm going to show you now the permission, as you can see, it is able to be read and written by anyone. So if I'm going to change the permission and lock it down, now if we say the new permissions, as you can see, it's logged in. And now if we are going to restart the Docker container, and then after that, if I'm trying to access it using unauthorized or I if I'm trying to confirm an unauthorized access is blocked, I'm going to use this command. So as you can see, permission is denied. The attack from the earlier is does not longer works. So the fix was easy. It just was the permissions, and now whoever wants to read the secret or retrieve the secret by changing the permissions, they won't be able to. So now I am going to try to patch the backup end for the rate limiting part. So what I'm going to do is first try to get a token and then save it in a variable. And as you can see here, I'm going to try to use the same test using the NGINX proxy where I have limited how often the requests go through. So as you can see, if I am going to test it through NGINX proxy, and the port I used was 8888. So as you can see, after the third request, it is 429. That means it starts blocking and it fixed. So first few requests went through, then it starts blocking. So overall, I confirmed most flags findings were false alarms, but code 2 real issues, a way to steal login access from one file, and a backup feature with no limit.